Hello, CC3 students, and welcome back. In today's video, we are going to go over slope. Now, we've gone over slope before, but so far in this class, we've only used slope to graph lines. Here's a point, here's the slope, here's the function, blah, 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 graph the line. We're going to actually work backwards today, and that's something that is sometimes difficult for students to understand. But I think that once you get started in it, you'll realize that you've already been doing this the whole time, so it should be pretty quick for you to pick up on. In today's video, we're going to be looking at examples from the worksheet practice. So if you want to be able to follow along, I would pause the video now and print out the worksheet, or at least have it open on your screen, or at the bare minimum, have it written out on a piece of paper. And we're going to go through the first examples from each section together and going over kind of the thought process for each one. So without further ado, here we go. Okay, so here's your worksheet practice. There are 3 sections. You can tell by the pages. So the first section asks you to find the slope of each line. And there are 6 different graphs. We'll go over graph 1 and 2, and you'll notice the graphs already have specific points set ahead for them. In section 2, it says to create a table to find the slope of each line through the pair of points. Now this seems brand new, but we've actually done this before. And then in the third section, it's find the slope of each line that is in slope-intercept form. And Mr. Adams went over this concept in your video practice last week. So in the first section, we'll be doing numbers 1 and 2. In the second section, we'll also be doing numbers 7 and 8. And then in the last section, we'll be doing 13, 14, 15, and 16. So we're going to go through a grand total of 8 examples today. So without further ado, let's get started. Okay, so here we go. Slope, as you can remember, right, is always our change in y over our change in x. Change in y is also sometimes called your vertical change. So how far am I traveling up or down? And change in x is also called your horizontal change. How far am I traveling right or left? So when we gave you something of a slope that was like 1/3, that would mean going up 1 and right 3. Or if it was -2/6, which would have been simplified, you would go down 2 and right 6, okay? I always like to say that the rate of change is always right. So in other words, you're always moving, and this is just me, not everybody says this, you're always going to move from left to right. My handwriting's not great using this thing, but oh well, we'll work on it. So you're always moving from left to right, and that's how I teach this, which is not how others do, but it's just something that usually makes it a little bit easier to understand. So let's take a look at our first example here. So we have a line, okay, and we've got 2 points on this line. So what I'm going to do just for this example, and you don't have to do this for all of them, is we're going to write out the ordered pairs of these points. So this first point here, it looks like this first point is at -2, 2. That's where this first point is at, right here, okay, because I'm at -2 for the x and 2 for the y. And it looks like this point here is at 0 because it's on the y-axis, 0, -3. So this one's actually an example of a y-intercept. This is at 0, -3. So to calculate the slope, we have to find, and again, we're starting on the left point and then moving to the right point, okay? So from there, we're going to start at this point here. And we're going to calculate how far do I travel up or down and how far do I travel left or right to get to this point here. So we're going to call this point 1, and then we'll call this point 2, okay? So how do I get from point 1 to point 2? So to do that, we first calculate your change in y. Change in y is always first, followed by your change in x. So I'm going to do this using 2 different ways of thinking, and then I'll do it a little bit quicker over here. Notice what the y value is of 0.1. The y value of 0.1 is at 2. That looks a little weird. I'm going to get rid of that. So the y value of 0.1 is at 2, and the y value of 0.2, oops, why isn't this working? Y value of 0.2 is at -3. So if I'm starting at 2, right, and I have to get to -3, notice how to get from 2 to -3, I'm going to have to subtract. What does that look like in the graph? Well, starting from this point to get here, how far do I travel? I'm going to have to travel down. So if you look, I'm traveling down 1, 2, 3, 4, 5. But this is a negative change because I'm traveling down, and to get from 2 to -3, that change would be subtract 5. 2 minus 5 is how I get to -3. So over here in my slope, my rate of change or slope and a change in y is -5 or subtracting 5. Okay, so to get from point 1 to point 2, I had to go down 5. Now, how do I get over to the next point, right? Because I've gone down 5, which is great. Oops, let me get out of this. I've gone down 5, which is great, but now I need to go over to get to point 2. So now I'm here, and let's see, the x value of point 1 is at -2, and the x value of point 2 is at 0. How do I get from -2 to 0? I'm going to have to add, which means my change in x is going to be positive. So after I go down 5, let's count. Go right, 1, 2. And that's a positive change because I'm starting at -2 on the x and I'm ending at 0. So this is a change of +2. Okay? So again, we started at point 1, which was on the left side, and then we went down 5 and right 2. Now, slopes are always simplified. So I wouldn't leave this as my final answer because I wouldn't have like a -5 over a +2. I would write this as a simplified fraction. What is a negative divided by a positive? A negative divided by a positive is always going to be a negative. And then 5 and 2 can't be simplified. Like I can't divide 5 by 2 or do anything like that. So my final answer is just -5 over 2. And there's your final answer for number 1. Okay, so again, change in y over change in x. I like to move from left to right, and then that's kind of the idea behind it. Now, you don't have to write out the exact coordinates. You don't have to write out the points if you don't want to. There is a way to do it without writing out the points. So let's go ahead and we're going to look at example 2 here. And we're going to calculate the slope, but this time we're not going to write out the coordinates. We're just going to use the graph. Okay, so starting on the left, this will be my point 1, and this will be my point 2. I like to kind of write that out. Okay, so how do I get from point 1 to point 2? The difference between this graph and this graph is here I had to move down first to get from point 1 to point 2. But here, I don't move down to get to point 2. I'm going to move up to get to point 2, which tells me something about my change in y. What do you think that tells you about your change in y? I bet most of you are able to get this, but we'll go through it just in case. Let's see. If I'm traveling from point 1 to point 2, I'm going up 1, 2, 3, 4, 5. Is that a positive or a negative change? Well, if I'm traveling up, that means my y value is increasing. That is a positive change in y. That looks a little weird. Let's try to get that a little bit better. That is a positive change in y. So as opposed to this one, which was a negative change in y, this is a positive change in y. Now, I'm still not at point 2, though. I have to move to the right, and it looks like I'm moving to the right 1, which is always a positive change if you move to the right because your x is also increasing. So this time I had a positive change in y over a positive change in 1. Okay, so I went up 5 and right 1. What is that simplify? Because we don't want to leave it like this. This shows the changes, which is great, but our slope is always going to be a simplified fraction. So what's a positive divided by a positive? Well, that's just a positive divided by a positive is a positive. And what's 5 over 1 simplified? 5 over 1 simplified is just 5. Okay, now notice, what do you see? Like, what should stand out to you about graph number 1? What stands out to me is that this graph is going down from left to right. If it's going down from left to right, that's how I know ahead of time that it's going to be a negative slope. So if it's going down from left to right, I already know this is going to have a negative slope. And if it's going up from left to right, then I already know this is going to have a positive slope. So there are things that you can do, like noticing it's going down, noticing it's going up, and that's how you can double check your answers as well. All right, so you will, from these two examples, hopefully that gives you enough to be able to do the rest of the examples in part 1. Let's go ahead and look at part 2. Okay, so here we are in part 2. This one, it has us creating a table to find the slope of the line through each pair of points, and then again, slope is change in y over change in x. So when it says create a table, it means create an XY table. So notice that these are two different points, right? The first value in the coordinate is always x, the second is y, the first is x, the second is y, right? These are just XY coordinate pairs. So what we're gonna do is we're gonna take these 2 points and we're gonna put them into an XY table. So I'm just gonna draw X and Y, make a little T chart here as best as I can. Okay, that's all we need. And then I'm just going to put these 2 points in the table. So here's point 1, we'll go right here. 3, -8, right? There's point 1, X and Y, and then we'll put point 2, whoops. That didn't work out too well, did it? Let's see if I can do that better. We'll put point 2 right there. That works better. I'm trying this new tracks out and it's not great. Okay, cool. So there's point 1 and there's point 2, right? So let's see. Oops. Oh no. There we go. Whew, I almost got rid of all of them. That would have been terrible. Okay, so I'm just going to get rid of these arrows. Otherwise, it's going to be really confusing. So remember, slope is change in y over change in x. Consider this just like calculating the rate of change. So we're going to start with our change in y first. How do you get from -8 to +7? If you have a number line in front of you, by the way, this would be really great. So getting from -8 to +7, I'm going to have to add something. What would I have to add? Well, here we go. Let's think about this on a number line. If this is my number line, and here's -8, right? And I have to get all the way to +7. What's in between them is 0, right? So how do you get from -8 to 0? You would have to add 8. And then how do you get from 0 to 7? You'd have to add 7. Well, what's 8 plus 7? That's a grand total of 15. So in other words, the change from -8 to +7 is +15. So in this table, my change in y is +15. Over here, now let's calculate our change in x. This one's a little bit easier than this one because it has smaller numbers to deal with. I'm starting at 3 and I'm ending at 0, right? So if I look at a number line here, I'm starting at 3, I'm ending at 0. I'm going backwards, which means I'm subtracting. What am I subtracting here? 3 minus what is 0? 3 minus 3 is 0. So my change in x is -3 here. +15 over -3. Now remember, slope is simplified. So I cannot leave my answer as just a rate of change like this. I need to simplify this fraction. So the first thing I see is that I have a positive divided by a negative. Well, a positive divided by a negative is always going to be negative. And can I simplify 15 divided by 3? 15 divided by 3 is 5. So +15 divided by -3 is -5. So the slope of number 7 is -5. Put a little bit of divide here. Okay, let's go ahead and do the same thing with number 8. So again, these are just XY coordinates, X and Y, X and Y. So we're going to make a table, X and Y. Okay. All right, point 1 is going to go in our first slot. So we have -20, 20, 18. And then point 2 is going to go in our second slot, 1, and 11. The reason I'm showing you this is because students oftentimes make the first mistake is that they don't put the points in the table correctly. So I want to make sure we put our points in the table the right way. Okay, now let's find our slope, our rate of change, right? Our rate of change is we find our change in y, and then we find our change in x, and then we'll simplify it to get it to a slope. Okay, so if I start at 18 and I end at 11, so on a number line, think about a number line. If I start at 18 and I end at 11, I have to go backwards, which means I am subtracting, right? So I'm going to subtract. What am I subtracting to get from 18 to 11? I'm going back 7. So my change in y here is -7. Okay. Now, over here with my change in x, I'm starting at -20. Here's -20, and I'm ending at 1. So I'm moving, this time I'm moving to the right, which means I'm going to have a positive x change. Well, let's see, zeros between them. How do I get from -20 to 0? I would have to add 20 plus 20. And then to get from 0 to 1, I'd have to add 1 more. So my total change is 20 and 1. That's a change of plus 21. So my y change was -7. My x change is positive 21. And that shows your rate of change. So this shows the two changes, but slope is simplified. So in our final answer, we need to simplify this fraction. Okay. What's a negative divided by a positive? That means it's going to be a negative. And then 7 and 21, now this is a fraction that I think can be simplified. Does 7 go into 21? I'm pretty sure that it does. So 7 is 7 times 1, and 21 is 7 times 3. So if we took the 7s out of there, we're left with a 1 in the numerator and a 3 in the denominator. Oops, that looks kind of weird, doesn't it? We're going to get rid of this guy here. So our final answer here is -1/3. Yeah, just like that. So again, you've done this before. You've made a table, or you've been given a table of points before and asked to calculate rate of change. So I know you know how to do this. The only difference is now you create the table, and instead of finding rate of change, you're finding slope, and the only difference between slope and rate of change is that slope is simplified. All right, we're going to go ahead now and wrap this up with our last section, which is the easiest section to understand. And then I'll show you something kind of cool that happens at the end. All right, so here we are in our last section. We'll go through 4 examples in this section just because they are pretty quick. So I anticipate that you'll be able to understand that really well. Now, as Mr. Adams pointed out in the last video, which was graphing lines using slope and the y-intercept, this is something called slope-intercept form, and you might have seen this before in your 8th grade classes or whatever. And whenever you have an equation in slope-intercept form, it gives you 2 pieces of information. It gives you the slope of the line, right? Hence why it's slope-intercept form, and the y-intercept of the line. So here's the idea. In this y equals mx plus b, m is always your slope, and b is your y-intercept. So in other words, think of it like this. It's almost like y equals the slope times x plus the intercept. So whatever you're multiplying by x, that's the slope of your line, okay? So really, this is pretty simple. All you do is you look at the equation, you go, okay, y equals -1/5 x minus 4. This is our y-intercept, because if I plugged in 0 for x, so if I plugged in 0 for x, this would all just be 0, and I would be left with y equals -4. So the y-intercept here, this is not what it's asking you to do, I'm just making a point, is 0, -4. Now, knowing that, that's not enough to graph a line. You would also need to have the slope. Well, the slope is really quite simple. It's just going to be the number that's multiplying x. So in this case, the slope, the number that's changing x here is this -1/5. So the slope here is our change in y over our change in x is -1/5. Now, I purposely put the negative in the numerator because if you remember what I said in my old video, I always like to move right with my slope. So this tells me I'm going to be moving down 1 and right 5, or in other words, my graph is going to look something like this when I actually do end up graphing it. So that's why I like to put negatives in the numerator. That's just my preference, okay? So this is pretty simple. The slope is just the multiplier of x, okay? So let's look over here at number 14. Again, if I were to plug in 0 for x, this would just be 0. Again, it's not asking you that, but we have in this conversation. And my y-intercept would be 0, 3. But it's not asking me for the y-intercept. It's asking me for the slope. So let's go ahead and find the slope. Again, the slope is the multiplier of x. What is being multiplied by x? Well, all I see is this like negative sign. What does that stand for? What makes x negative? This is actually really difficult for most Algebra 1 students. This is a hidden -1. I know, -1 times x is the same thing as -x. So in this case, your slope would be -1. Now, if I were graphing this, I wouldn't leave it as -1. I would write it as a ratio. I would write it as -1 over 1, because this tells me I'm going to be going down 1 and right 1. And my graph's going to look, again, something like this. But for the sake of this assignment, because slope is always simplified, you can just leave your answer as -1. All right, moving on. Let's take a look at number 15 here. Again, if we were asked to graph this, we would plug in 0 for x, which would leave us with y is 5. So our intercept would be 0, 5. But that's not what we're asked to do. I just like to do it anyways. So here, let's look at, okay, what is being multiplied by x? It looks like in this case, we have 3/4 is being multiplied by x. And 3/4 is pretty straightforward. It's positive. It can't be simplified, or it can't be expanded in any way. So our slope here is just 3/4. That means we're going to be moving up 3 and right 4 if we were to actually graph this. And my graph will look something like this. But you're not being asked to do that. Again, you're just asked to find the slope. Now, this is a tough one. Why do you think this one's tough? Well, it's missing something, isn't it? It's missing the x in the slope-intercept form. There is no x here. Well, what does that mean? Well, if there's no x here, that means it was multiplied by something that caused it to disappear. Think about it. What did we plug in for x for all of these to make that whole term disappear and just end up with what was on the end? If you think about it, we plugged in 0. 0 makes this whole term disappear, and then you're just left with y equals a number. So that means this is kind of a tough one, which is why I'm going over it with you. This is the same thing as y equals 0x minus 3. Because think about it. What's 0 times x? 0 times x is 0. You would just be left with -3. So what does that mean about our slope? Our slope here is 0. So if I had to write out the slope of this one, I would say my slope is 0. And that would be my final answer. But if I were asked to graph this, I would want to write this as a change in y over a change in x. So I would want to write this as 0 over 1, meaning I am not traveling up or down. So there is no change up or down. I'm just moving to the right, and my graph would look something like that. Now, again, I did way more than you needed to for this. I went into a lot more detail. You don't have to go into that much detail. So let me show you what's really nice about this worksheet practice. If you scroll all the way down to the bottom, what did we provide for you but an answer key? So when we're looking at your work here, it is more important to see the actual work done than it is to get the correct answer, because you guys can see the correct answers. They're all right here. So as you're going through the rest of your worksheet practice, really use the answer key to help you out. Okay, that is it for today. So go ahead and get that worksheet practice done as soon as possible and submit it through Google Classroom so that we can give you some comments. And then tomorrow's video will go into comparing linear functions using the slope. So it's absolutely essential that you get this one done first so that you understand how tomorrow works. All right, have a fun time with your worksheet practice and slope, and I will see you all tomorrow.